Hello and welcome to the first release of the Pointcloud engine for Unity. The project contains two converters as well as two projects, PC Core and PC Converter. The core is just your jump point, everything's ready to go. There are a whole series of projects which I'll show you, and the converter is used for converting mainly static cells or doing merging of point clouds or converting triangle meshes into point clouds. In the core project we have a few samples to demonstrate all the features available in the plugin. The plugin is actually contained in the assets plugins folder, and there it is there. It handles the loading and deletion of all point clouds. The drawing happens in the shaders, which is the compute shader. So there are basically three folders within the Pointcloud engine, which is the camera scripts. These two, that is for the left eye, that controls the main rendering. The right eye, if using virtual reality. There are a few camera controllers, orbital, first person, and flying. We're mainly using the flying here, so you can see that in action. This first sample is the basic, and you can see the left eye camera, left eye main script for the Pointcloud rendering. It'll merge. It basically draws to the screen and merges with Unity scene, so you could add meshes and point clouds if you wanted to. It's all set up ready to go. I'll just go over a few of the features. Here we have use noise reduction. If you check that, when I press play, you'll see that nothing shows up until the camera has moved. This is a way of preventing noise, so it'll only update or redraw the scene as the camera moves by orientation or position. Mainly useful if the meshes, the point cloud is very noisy. It's not very good for virtual reality because the camera is always moving because it's attached to your head. When you want to use virtual reality, you will check VR and attach your right eye camera to the camera RE slot here. When using the measuring tool, you'll select pickable and attach a cube to this slot here, and that cube will be stretched between the start and the finishing point, just as a measuring tool. You can modify these scripts however you want. It's just to demonstrate basic functionality. Also, if you are using picking, you'll have to just create another camera and attach it here to camera PP. This is because it captures the screen. It's picking from the screen, so it'll yeah, it is needed. So first up, we have to show you some basic parts of the project. Here we have an angel, and it has 14 million points. In the script, it just prints out as it's loading. You can change it. You don't need to print anything if you don't want to. So we press play, and as you see, you have quite a good frames per second there. However, keep in mind you are looking at around, depending on your resolution, worst case scenario, maybe 60 million points. With an optimal good hardware and everything, you can get from 80 to 100 million points before dropping below 60 frames per second in standard. With virtual reality, you are limited to around 20 million points per eye. So that is why there are two versions of the Pointcloud plugin. Not the plugin, but two versions of the Pointcloud. There's Pointcloud 1 and Pointcloud 2. And Pointcloud 2 is basically a static cell, and I'll show you what that does later. But right now, it will basically take a capture from a position in space, recording the what the camera sees and saving it to a file, and that can be later streamed in as a cell. So you can capture as many cells as you want, as much as your hard drive space will allow, and stream them in. So basically it would be great with teleportation. There are more advanced features that are not currently in this plugin. Only the stable features are in this plugin. The expanded version, which relies on .NET 4.6 because it uses memory map files and random access, that will be in a future release, but currently that is dependent on Unity 2017 as it becomes more stable. Unity 2017 is great. The thing is, there are still some issues with virtual reality and stuff. With I personally had trouble with the right eye not showing up. It worked in the editor, but not in the exe, and I had to do a lot of messing around to get that to work. So until those things are sort of stable, and the 4.6 version has been more thought out, and then I'll release that as well. Obviously for free for everyone who's currently purchasing this version. So first up, I will explain that this debug visual, when you select this little widget here, you can destroy it. When you first attach the script, so if I remove it, if I go to my Pointclouds and Pointcloud draw script, chuck that onto here, connect it to the camera, and then I will just drag a version 1 Pointcloud to the script, and then create the debug visual. This is not rendered into the rendering window because it is internally on this editor layer. So if you are starting a new project and wanting to do everything yourself and start a brand new clean slate, you will have to create a layer called editor layer, and that will, as it's spelt there also, and that will make sure that these do not show up on the rendering window, only in the editor window. Okay. Next we have instancing. Here we have a hedge which is made of 10 million points, and once I hit play, instancing only loads one instance into memory, and then it will just redraw the other point clouds based on that original data. So the script is just referencing the original data and modifying the matrix. So you can have a look at those scripts to understand how it works. As you see, we're up to around 60 million points, and I'm getting about 60 frames per second here. Once we add LOD, level of distance, or there's one that describes the level of distance, but we'll go straight to instancing. Here we have 132, I think, instances of this hedge. So, and as you see, we're getting around the same frames per second, but it's as you zoom out, you can see the slight change. This is controlled by the runtime decimation, and you can set that manually by adjusting resolution X or resolution Y on the script, the Pointcloud script, or you can use the LED version, which uses a distance to the Pointcloud to control this. And as you see, you can, depending on, this also has bounding box culling as well, so that's why you're getting higher frames per second when you're around the center, because you're not drawing everything. And as you look at everything though, you see the frames per second drops, but that's still quite a lot of points to be drawing. The measuring tool, we'll have a quick look at that. basically just select 2 points on the point cloud, and it will stretch a cube between the start and end point. We'll work on any point cloud. Just be aware that you really want to be working with a dense point cloud so you can actually select the faces, because the what is happening is it's actually a 2D picking from the screen. It's picking the 3D location from the screen coordinates based on a floating point texture, which is why you need the additional camera to plug into that script. So study every project. They all demonstrate different things and all the features, and you should be good. Here we'll just have a quick look at the volume culling. This basically will just allow you to isolate certain parts of a point cloud. Here we have 2 point clouds. One is a skeleton and one is a organs, I guess. If we have a look at the script, you can see that for the skeleton, volume culling is enabled, and currently culling inside the volume. Inside the volume is visible, sorry. So if we unselect that, you'll see that it's inverted. These values here basically control the extents of the volume. So if I adjust these up and down, you can see that you can fold back. Say if you were looking at some mechanical part, you could strip it back and see each layer. So that's a handy tool to have as well. Alright, so next on to the converter. As you see here, we have merging point clouds, static cell capture, stream load, which is basically a variation of the static cell. What it will do is allow you to place multiple point clouds inside a single, not a single file, but it basically one contained object that can then stream in each point cloud as it's needed, as a series, like a cells, So then you also have the converter from triangle meshes to point cloud, which will take in, a FBX or whatever OPJ sort of triangle mesh that Unity uses, and you can just connect that and press play, and that will convert to the triangle mesh. Before we continue, we'll just go through these. Actually, I might do that in the next video. If you are interested in this or have any further questions, just contact me at david@oddityinteractive.com, or have a look at the contacts emails. You can contact me from one of them. In the next video, I'll go over the converter. We're using Gumroad for selling, for purchases, in-store purchases. This project is not on the Unity Asset Store and probably won't be, due to the fact of needing external converters, and I think that would just be more complicated to put it on Unity Asset Store, so I'm not even sure if you can do that. So for now, it's just selling through Gumroad, or if you want to contact me directly and you feel you prefer to pay for it with PayPal directly to me or into my bank account, then just contact me. We can work something out. Yeah, so okay, I hope you enjoyed it, and I hope you find it useful if you decide to help support this project and where it's going. Okay.